Hello everyone, this is Jeff from the Ozark Mountains in Missouri, USA. This was kind of an impromptu video because, well, I needed to fix my little heat gun. It's perfect for electronics work, for preheating circuit boards before soldering on them, and for heat shrink tubing. It's relatively small, so you can get in tight areas and equipment that you're working on, and it's not so hot that you're going to burn something up. So let's dive right in and take a look. This is a little heat gun. It doesn't get very hot, but it is perfect for heat shrink tubing and preheating a circuit board when you're going to be soldering on it. You don't need a heat gun that'll, be as hot as the temperature of the sun when you're doing that. So it recently developed a problem where it doesn't always want to start on the first try. It's got two speeds, high and low, and I've used it already tonight, so it's probably going to start just fine. Yeah. And I thought originally it was an electrical problem because the strainer leaf broke, and maybe that had pulled on the switch. But then I got to thinking about, no, it always starts after you get it started that first time. So maybe it's a mechanical problem, and once it's heated up a little bit, then it's fine. And it is kind of noisy. It's kind of hard to tell because it's noisy anyhow. I'll hold this up near the camera and we'll see if you can hear the kind of whininess or screechiness of the motor above the normal loud blowing sound. So I thought we'd do a really quick impromptu video this evening because I need to order from the supplier I got this from. And since I use it all the time, I need to order another one if this one isn't going to be reliable. So I think the first test we'll do is I'll go stick it in the freezer for 10 or 15 minutes and cool it down. Then we'll see if it fails to start again. Okay, we have our fresh out of the freezer heat gun. Heat gun in the freezer. At any rate, we'll try to turn it on here and see what happens. Ah, of course. Let me listen to it. Okay. My dog's in here helping out. This is a little bit. If you can see her, she might be off camera. Okay, so we've got some light oil, and I have the heat gun unplugged, and this is quite impromptu. But I thought it might be interesting because it's more of a mechanical issue, I think, than an electrical issue. And the cover, that is just your standard, oh, that's still a little hot right there. Your standard little bitty motor, that's a technical term. And our power switch. Oh, you see this right here? This is a diode. I would bet dollars to donuts. And in low speed mode, which would be like this, the toggle switch is always, when you have it toggled this way, it's sliding the contacts this way and it's contacting here. When you go like that, sliding the contacts that way, make a contact there. So just using this diode here to chop half of the signal off so you get half the speed. Okay, and half the heat because the switch is in series, and we have like a temperature sensor here, I would guess, for safety. And there's probably an extra heating element in here that's dropping the voltage down to power this motor. There are, I'll get you some close-ups of this, 4 little diodes on this motor. So it's a DC motor, and yeah, it's 19.1 volts. So there's an extra resistive coil inside here that's dropping the voltage down enough to drive this motor, and there's some diodes there that are rectifying things. So there is the little circuit board, and if Get around to the back side here. We can see the diodes. So the red wire and white wire here are the 110 volt into the heating element, and we've got some dropped voltage off of that rectified through the diodes to power the motor. Not sure if you'll be able to see that, but that solder joint there looks rather sketchy. And those are nothing to write home about. Let's see, there's our, oops, heating element's getting in the way there. There's one bushing and there's one up here under the fan. So I'm going to oil those and touch up the solder there, and we'll see what happens. Okay, I'm going to wrap the rag around here because that was awfully hot. I'm first going to try to touch up this diode soldering because that looks rather sad. Now this motor and this solder is on the cool end of things, so it's not particularly high temperature. Okay. A little flux. Get a medium-sized, about 2mm chisel tip here. Yes, got everything heated up good there. Okay. Just going across the motor terminal and both diode pads at the same time. Yeah, now it's flowed out much better. Okay. All I have is 3-in-1 oil, which isn't the absolute best for this, but it should do the trick. What I'm going to do is put a drop. Wait, if you're wondering about that, and this other end I'm not going to be able to get to because that motor is, this is pushed on there tight, and if I try to pry that off I'm going to break it. Looking through the hole here on the motor, the armature doesn't look too bad, so put one more drop of oil on that, put it back together, and see what it does. Slide the heating element back up in, wires in place. This is approximately right. There we go. Pop these two screws in. Okay. Pop the shroud on there. Little screw. Pop the switch in. That feels good. And we have the bail. Okay. like it. So that way you can set it in. Plug it back in and see if it goes boom. Well, to be honest, it doesn't sound much different. But maybe that'll buy me another week till I can get a new one in. Like I said, I use this nearly every day, and I've had it 6 or 7 years, so I guess I've got my money out of it. So when you have something like this, never, that's not working right, never be afraid to take it apart and have a look. It's already broken, so what are you going to lose? Most of the time, this little bronze bushings on the motors will dry up. You put a drop of oil in there, and always be suspicious of solder joints, especially in something that goes through a lot of thermal cycles. They tend to crack. So, okay, it's about 24 hours later. I haven't used this, and ignore the blue tape for now. We'll explain that in a minute. I'll try turning it on and see what happens. Well, previously, if it sat that long, it wouldn't turn on right away. So I think maybe we breathed a little new life into it. Now, the purpose of the tape is the strain relief was broken right here. So I've super glued just those nubs back together, and I'll wrap some more tape around here and fill this in with E6000, which is a blue. It dries kind of flexible, so hopefully that'll keep that strain relief working for at least a few more months. Let me get you a close-up of that. Okay, you can see right here the strain relief broke, and you can tell the cord is pulled back some from the strain relief, and you can see the opening there. So I'll fill this full of E6000, and we'll see if that makes a good repair. Got you zoomed in there a little bit. Now this E6000 is white. I normally get the clear, but I accidentally got this last time, and it works just as well. And for this application, I really don't care what the color is. So I'm going to try to just squirt some right down in that slot. And just for good measure, I'll poke some down in there with my screw. And I'll get you zoomed in on that. Put that there. Hold the whole thing in place while it sets up. Okie doke, so this tape just keeps the glue off the butt of the heat gun. This tape I only wrapped around one side, squirted the glue down in the slot where it was broken, and then wrapped it around tight to make a form. Hopefully that'll make a neat looking job. And just for good measure, a little tape around the cord and around the body of the tool, just to keep everything in place while the glue sets. Kind of a top tool tip here on your roll of tape. If you fold back over the last centimeter, ½ inch, and tape it to itself like that, you'll always be able to find the end of the tape and not have to go searching for it, especially on like Captan or something like that that's really difficult to find. Okay, it has been another 24 hours, so we'll check out that wonderful glue job and see if it still works the first time around.
This blue masking tape is painter's tape that releases a little earlier. It kind of works for that. I'll get you a close-up of this, but let's see.
Let's see if it works. Alright, I think we breathed a little more life into this. Let's get a close-up. Okay, here's a close-up of the glue job. this is just loose stuff right there. And oh, get you back here where it's focused. So that's not too bad. It looks a little ugly because it's not color matching. And there's a bit of a void right there, which I might have to fix. Not sure how long this is going to last, but we'll eke a little more time out of this. I hope you found this episode interesting and that it might encourage you to try to fix your own power tools. Just be safe, make sure they're unplugged from the mains, and use a little common sense, and it never hurts to do a little research on the internet. It's great for that, I hear. Until next time, bye.